You said you didn't subscribe to the internet is burning philosophy. What do you subscribe to?
Well, in any emergency, you can look at the impact of that emergency, or you can respond to that emergency with being a first responder, if you would. I'm sure when a professional firefighter arrives at a fire, they don't look at it as the world's burning down. They look at it as a problem needing to be solved.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. Today, we wrap up Season 3 with another engineering powerhouse, Amazon Web Services VP of Engineering, Wayne Duso. By some accounts, over 1/3 of the entire internet is run by AWS, including sites you almost certainly use like Netflix, Facebook, LinkedIn, Twitter, and Twitch. So AWS's tech has to be some of the most advanced in the world. Wayne Duso spearheads AWS's cloud, edge, compute, and storage initiatives. Wayne, thanks for being here.
Good morning, and thank you for having me on the podcast.
I'd like to start a bit differently than we normally do. You have spent your career working on storage. Are there any moments of absolute terror that stand out to you where things were really going sideways?
That's a really interesting question. So I use tongue in cheek. I use this phrase for people from time to time. A lot of people ask me, "Why have you been in storage for as long as you have? Aren't you bored of storage?" The answer is no. I'm not. It's always changing. It's always growing exponentially, no matter what you do. We are fundamentally pack rats, and there's a good reason to be a pack rat, especially with the ability to use the data for training purposes today. So if your fundamental focus is compute and something goes wrong, you reboot. If your fundamental focus is networking and something goes wrong, you resend. And if your fundamental focus is storage, if something goes wrong, you rewrite your resume. So every day in storage and data, a near disaster could happen, right? Because durability is fundamental. Not losing people's data, not losing their bits, is fundamental. I won't say we have a lot of close calls, but every day is vigilance. So I don't have a lot of days where the world was coming to an end. I would say this log.j4 thing is as close, log4j, is as close as you're going to come to a near disaster. That is a level of meltdown that you could see in our business. But again, if you have the right monitoring in place and you have the right team in place, they don't turn into meltdowns. They just turn into all hands on decks.
A bit of a sort of Damocles of data storage, just kind of perpetually hanging over your head then.
Well, you look at, there's a lot of stories, and most of which you can't go into in great detail. But you hear of stories where networks are infiltrated, bad actors hang out in them for a long time, plant their little seeds everywhere, and then eventually are discovered. These are the types of things that will only continue to get more interesting. It's the kind of world we live in.
How did you know you wanted to become an engineer? Were there things as a kid, or was it later in college?
I didn't know I wanted to become an engineer. It was not a well-laid plan. I actually started off not knowing what I wanted to do in high school or in college. And it was my brother who had suggested to me in my floundering that perhaps I would want to take a course in programming. Just give it a shot. You might like it. Now, there was no evidence that was true. Zero. Well, I went along with it. And frankly, it was the first course in my life that I had ever aced. It was something that I was good at, and it was something that I had a lot of fun doing. Like sitting in front of, at the time, a terminal, punching in basic commands and forming programs was something that I was pretty good at. And then I went on to, believe it or not, went from a terminal to back to a card punch on COBOL. And after I'd taken that course, the state college that I was at said to me, "You need to leave. You need to go to a real school and pursue a real degree because we got nothing for you anymore." So I headed off to the flagship university for the state, which is University of Massachusetts in Amherst, and received my undergraduate degree in computer science.
Do you remember what that first computer was that you used?
Yes, it was a Control Data Corporation. I want to say 9,000, but I probably got the number wrong.
Do you look back nostalgically at punch cards, or are you glad that era is over?
I am happy that I can say that I have it in my belt, and it is completely irrelevant to everything that I do. And in many ways, it simply just dates me. So I'm happy. I'll hold it in my heart, nowhere else.
Fair enough. And then what happened after school? Where'd you end up?
So I ended up sitting on a couch between my junior and senior year, like most people do. Like the notion of internships when I was an undergrad didn't exist. An internship was making fried clams at your local fried clam box place. So the notion of actually looking for a real job didn't exist in those days. And my girlfriend at that time said, "You should probably get a real job." And I said, "Well, how would I go about doing that?" And believe it or not, we went to the phone book and we opened up the yellow pages and looked. We looked under C for computers.
Well, C for computer sure beats clams, fried.
And lo and behold, there was an ad in there for Digital Equipment Corporation, affectionately known by many of us who work there as DEC. And so I just simply called and I said, "Are you looking for any summer hires?" And they said, "Sure." So I came rolling in. I had just taken my course in my junior year of building operating systems and translators. So I had this wonderful 11 by 13 printer paper that we used to have. They used to come off of these big printers, and it had my entire project in there. And I brought it with me, had my little suit on, had it on my lap. And during the interview, one of the interviewers said, "What do you have there?" I said, "Oh, I wrote an operating system and a compiler." And we looked through it, and they said, "Okay, you're hired." So I ended up having my first gig as an intern at DEC. Had a great project writing a fully automated test system for what was then the first Ethernet products, networking products. And at the end of the summer, they called me into the HR office. And if you know anything about my background, being called into an office is never a good idea. Had spent a lot of time in other offices in my time. And I thought for sure something had gone wrong. I thought, did I borrow a pen and not bring it back? Let me think about this. And they said, "Well, you like a job when you get out of school?" And I said, "I would love a job when I get out of school." And they said, "You're hired." So I went into my senior year not having to worry about whether I was going to work at a clam box ever again.
Did that impact your academics senior year? I know I would have maybe been a little less motivated.
It's interesting. At that point, I completely flipped a bit, pun not intended. And I ended up being a very serious student. Like I could not get out of serious student mode because I worked pretty hard. I was a marginal student most of my life, and so by the time I got to college, everything was double down in order to focus. So by the time I hit my senior year, I just spent it taking courses I wanted to take versus courses that I thought would look good on my resume.
Flipping clams to flipping bits.
Flipping clams to flipping bits. That's exactly right.
What sort of engineering problems were you facing in the 80s, 90s, and even early thousands?
So I started my career building Ethernet-based devices, so things like routers and gateways and terminal servers and so on. And so the problems we were solving then were how do you build embedded systems on the original chipset we used was actually the one used in the Apple IIe, which was at the time, Rockwell 6502, which turned into the Motorola set of chips. So I went from 6502 to 68000 series. So I was an assembly programmer for the first 5 years of my career, probably a little bit more than 5 years. So the problems we were solving are those of embedded systems. How do you fit an entire operating system, user experience, contextual help system, everything else into a couple megs of memory and do so in a way which didn't waste a byte, didn't leak a byte. So you're really, really close to the machine. I wouldn't trade that experience for anything. In fact, recently, one of my sons decided to take up the trade, and everybody is so far away from what they're actually doing, programming a chip or a set of chips. They really don't know what they're doing. They're just writing some code. So I bought him a 6502, and I bought him an i7. You can buy both of them very cheap on the open market. And I handed them to him, and I said, no matter what you do, like, this is what you're controlling. I started here, you're starting there. Like, never forget that, you're controlling a chip. You're not controlling the universe or anything mysterious.
We'll be right back with Wayne Duso, VP of Engineering at AWS. I'm joined by George from Rome to talk about USB Type-C with power delivery. George, thanks for being here.
Thank you for having me.
So, George, what makes USB Type-C with power delivery unique and attractive for designers?
While previously the old standard of USB can only deliver power up to 7.5 watts, which is 5 volt and 1.5 amp, with the new USB Type-C with power delivery, it can now deliver up to 100 watts or 20 volts at 5 amps.
So is any device with a Type-C connector able to deliver 100 watts, or is there some sort of trade-off happening?
There is a distinction between a regular USB Type-C port versus a USB Type-C port with power delivery, or PD. In the case of the USB Type-C PD, there is a standard that needs to be followed, and between the source side, for example, a wall charger, and the sink side, for example, a laptop, there will be this handshaking or negotiation that goes on between them that finally will agree what power level that will be delivered.
How is Rome working to make USB Type-C power delivery more simple for designers?
The latest Rome's USB Type-C with power delivery devices are targeted for standalone operation. What this means is they do not require any managing by an external MCU, nor do they require any firmware. So this means for the customer side, faster to market and much simpler to design Rome's devices. And at the end, Rome's devices will take care of the handshaking inside, so the customer does not need to have any knowledge about the USB Type-C with power delivery standard.
Clearly, USB Type-C with power delivery is here to stay. It's not going anywhere. Where should designers go to learn more about implementing it into their designs?
Yeah, so I would highly suggest they go and check out Rome's website, which is rome.com. There, they will be able to find information about our USB Type-C with power delivery devices, information including datasheets, and also evaluation boards, which they can purchase.
George, thank you so much for being here.
Thank you so much for having me, and it's been a great pleasure.
And we're back with Wayne Duso. Wayne, you were involved in some of the first ever network attached storage systems while at EMC. Can you tell me more about those days?
Yeah, in fact, EMC was so every job that I've had prior to Amazon, and even Amazon to some extent, was a bit serendipitous. I'm so different than a new professional today, which they're very deliberate about. What school, what job, how to interview, when to jump, so on and so forth. I wish I was that clever, but I'm not.
I'm not either, if it makes you feel any better.
I'm okay with it, though. Not every well-laid plan executes perfectly, and some partially laid plans get executed pretty well. I was working at DEC, and I had gone to grad school on a program that Digital had, which promoted their engineers into getting advanced degrees. And in the early mid '90s, the degree everybody wanted to get was an MBA. If you had an MBA, you'd be a rocket ship to the stars. I couldn't do it. I just couldn't do it. I had to go get another engineering degree. Like, it was just in me. And so all my friends are going off to Harvard and MIT and Stanford and all these other wonderful places. I'm like, nah, I'm going to go get a graduate degree in systems engineering. I just need to do it. And they thought I was crazy. And when I came back, instead of going back into product development, I ended up in a research and development team under this wonderful gentleman by the name of Dr. Percy Zelnick. And they were building some of the earliest Ethernet-based appliances. And one of the appliances was file servers. It didn't exist then. NetApp didn't exist then. As an example, one of the pioneers of network-attached storage. And at about 1994, Digital Equipment Corporation started going through some tough times. It was shortly before they were acquired by Compaq, which was then acquired by HP. The R&D group I was part of, one day I was looking at Percy, and he had a strange look on his face. And I said, if you're looking to get out of here, I'm going with you. And he wouldn't say anything. A couple of weeks later, he assembles a team of 4 of us in his basement, and he said, there's this little company called EMC. They're a storage company, and they would love to build network-attached storage, and they have no networking people. And would you guys like to go? And I'm like, yeah, I'm in. Let's go. And so we ended up in a room in Hopkinton, Massachusetts, at EMC's headquarters. And if you know anything about EMC, one of the fathers of their primary product, Symmetrics, was Moshe and I. He's the father of storage. And Moshe is Israeli, so we're all his lieutenants, and so was Percy. And so I'm sitting in a room with all these folks, and they're screaming at each other in Hebrew. And I had no idea what they were saying. And at some point, were staring at me, and Percy turns to me, he goes, "It's a good deal, just sign it." So I trusted Percy implicitly, still do. And so I signed the deal, and we were on our way to creating EMC's network-attached storage division.
Did they know what to do with you when you showed up?
When we went there, everybody was still working on PCs and the like, and we walked in and we said, no, we need Sun workstations and we need connection to the internet. And they're like, yeah, nobody gets connected to the internet. We don't trust the internet.
They wanted networking, but they wouldn't connect to the internet.
No, this is how crazy it was, right? They literally they believe that, if they connected to the internet, all of their secret sauce bits would leak out. Oh, no. Right? And remember, there was no firewalls, there was no protection against what was going on in the internet, even though the internet was the size of a pea back then. So that was our condition for employment. 1, we want Sun workstations. 2, we want laptops, which barely existed. And 3, we need Mozilla running on our desktops.
Wow.
So we started there. We built EMC's first network attached storage products, and that went on to becoming, one of their major product lines. And one of the reasons, in fact, in the fullness of time, they were acquired by Dell. And so I worked there for 19 years, and that's where I really grew my career, from being a principal engineer to being an engineering manager to business development, product management, and then to general management.
Who was using network attached storage at that time? And what sort of storage volume are we talking about?
So to give you an example, I thought about this a couple of days ago. An entire 3 tiles, floor tiles in a lab, which I know whatever they are, 2 by 2, right? Whatever a standard rack is. 3 racks was 1 terabyte of storage.
Oh my goodness.
Yeah, and today you have multiple of that sitting in your laptop in a little corner, right?
Right.
So at the time, I was building a multi-channel broadcast server. So having lots of storage was really important. And we were selling these broadcast servers to broadcast groups that wanted to consolidate a number of broadcast channels into one physical location. And they needed the ability to record in real time, store, and then be able to broadcast in real time with the ability to splice. It was all done in MPEG 3. The ability to splice MPEG with commercials and content. And this was radical stuff at the time. Very few people could manipulate the internals of MPEG, and very few could splice without any disruption to the stream. In fact, we have one of the patents I have on my wall behind me. I had a whole bunch of patents. I tossed most of them away, but I kept one. And that one was the algorithms we came up with for MPEG splicing. And it was done by a handful of folks that I worked with at the time and myself. And so that was one class of customer. The other class of customer were early customers, same customers that NetApp found in their early days, who wanted to take file serving and move it from being on, mini computers and large timeshare computers onto a dedicated device. And this is when we went from taking software running on big computers, VAXs, if you would, and started moving them onto dedicated appliances. And, NetApp came up with their first toaster, right, which was a dedicated appliance. And so did Cisco come up with their first little router. And all of those were products that I directly competed with and now admire for their vision.
Safe to say things have changed quite a bit over the years. What about today's technology would have surprised past you?
That's a great question. The sheer scope and scale of what a single person can control, what a single person can influence. Just take this week's, as it's been advertised on the internet, though I don't subscribe to this term, the internet is burning down. We had a very serious, Log4j issue that has affected the entire world. And if you think about what caused that problem, it is a very, very simple, unintended result of a protocol, a simple packet form that can end up having this level of impact. I think if I look back and thought that was possible, given that what I was doing is programming a 6502, that probably would have surprised me.
For those who aren't familiar, could you describe the Log4j issue that popped up?
In a simple statement, the ability to have unintended consequences by parsing a protocol message, and within that, there is a string that can get logged. In this particular case, a reach out to an LDAP server, which, when processed, results in an executable statement. Innocuous as it seems, it reaches out to an LDAP server that was set up by a rogue agent that isn't an LDAP server, but in fact provides a response, which in effect is malware, right? That can be executed on the receiving system.
Remote code execution is incredibly serious, especially in something as prolific as Java. What has it been like this week inside of AWS?
If you know anything about AWS, security and operational excellence are the table stakes. So we have well-honed processes and well-honed mechanisms for inspecting the security of our entire estate, every millisecond of every day. And when something like Log4j happens, we go into all hands on deck mode.
Hi, a quick note from the editing bay for those of you who have been screaming at your podcast device for the last 2 minutes. The issue is called Log4j, not Log4j. Both Wayne and I mix it up, but hey, every good electrical engineer knows that when working with complex numbers, the J goes before the integer. So I'm going to say it's the software folks who got it wrong, not us hardware types. Anyways, back to our podcast.
It's important. What we do every day runs much of the internet, and we take that responsibility very seriously. I mean, just in the middle of this, as an example, we extend AWS all the way out to the far edge where customers are, where any customer is, and where anyone is. And the tornadoes that are happening in the Midwest and southern part of our country right now, the US, we deploy teams of disaster response folks with AWS equipment, specifically Snowball Edge devices, which run the same APIs and the same applications you can run on cloud at a remote edge that doesn't have an internet connection and may not have 5G or 4G. So, we take all of this pretty darn serious. So in the middle of all of that, Log4j hits. But all of that needs to continue regardless.
You said you didn't subscribe to the internet is burning philosophy. What do you subscribe to?
Well, in any emergency, you can look at the impact of that emergency, or you can respond to that emergency with, if you would, correcting it, being a first responder, if you would. When a professional firefighter arrives at a fire, they don't look at it as the world's burning down. They look at it as a problem needing to be solved. So when log J4 hits, we look at it as a problem, just like any other problem that needs to be solved. And we approach the problem in that way. In many ways, we're engineers, right? We look at every problem, break it down into its parts, put a plan together, and go at it.
Is the log4j exploit a one-off? It's pretty clever.
All of these hacks are always clever. And when you see them as a designer of protocols, it's a little embarrassing.
When you say it's embarrassing, why is that?
Well, we should always design for safety, and we should always be thoughtful of every possible attack vector, especially when designing protocols that span the entire internet. And we've seen other like problems in the past with, simple overflow bits in protocol packets that can be used to result in some attack vector. It's serious work, what we do.
Do you feel like cybersecurity is a bit of an arms race? And if so, how do you keep ahead?
In any domain where there's an opportunity to take advantage of that domain, you're always going to find clever people who are going to try. So whether it's the internet or physical world, no matter what security you put up, you put up a fence or a camera or malware detection or ransomware detection, you're always going to find somebody who wants to get past that. It's human nature. So we're always vigilant, and I'm not sure I'd call it an arms race, but it is always every day an active exercise in protecting assets, and this asset happens to be the internet.
We'll dig more into that in a moment, but first, a word from our sponsor, Infineon. Infineon is a world leader in semiconductor solutions that link the real and the digital world, making the IoT what it needs to be: real, secure, easy. The company's wide range of solutions, spanning sensors, microcontrollers, actuators, communication modules, and security components, create the backbone of each IoT system, unlocking new markets and applications. This makes Infineon your partner for unleashing the power of the Internet of Things. Together, we make IoT work. To learn more, please visit www.infineon.io. And we're back with Wayne Duso. Wayne, today you're at AWS, and I find it fascinating that Amazon went from a bookstore, which had some pretty good data per square foot in that era, into online storage. What did that move look like, going from online bookstore to top 5 tech?
It is an interesting story, isn't it? You just never know where a company's going to go. So a couple things on that. One, in a time I transitioned from DEC to EMC, which is in the mid 90s. I really wish Amazon would have called. They didn't. They didn't call until roughly around 2010. So there was an interesting sort of strong 12 years in there that they went from being a bookseller to being what is now, as you said, a major vendor in the IT business.
A third of the cloud infrastructure market. That's no joke.
It's as the originator of what has become public cloud, it's pretty considerable. So let me answer your question. Andy Jassy, who's now the CEO of Amazon, at the time was a fresh grad student out of Harvard. And Andy always wanted to be a sports broadcaster, and coming out of school as an undergraduate, Andy went into sports broadcasting, and he realized a few years in that it was going to take a lot of years to ever get on TV. Getting in front of the camera was not easy. So Andy decided to go back to Harvard. He was originally undergraduate from Harvard. He got his degree, and he got this call from a little company in Seattle, this bookseller. And there's very few people there at the time. So Andy decided to take the job, and in short order, he ended up becoming the technical assistant to Jeff Bezos. And as his technical assistant, at some point they had decided during this period that in order to grow Amazon, and Amazon originally was being grown on the same enterprise class hardware that everybody grew the internet on, and every enterprise grew on. And by and large, the equipment came from, I think they were called the four horsemen of the internet. It was Sun Microsystems for compute, EMC for storage, Cisco for networking, and Oracle for databases. And every stack was made of something that looked like that. The problem is that, one, you have to buy it in really big chunks. There wasn't any small chunks at the time. You had to buy floor tiles at a time. Two, though incredible product, the vast majority of the features and capabilities in those products weren't used by Amazon. So you were paying for a lot of stuff you didn't need. And the internet was a different model. Your time for recovery, your time for detection and recovery was minutes, not hours or days. And in those days, a good SLA was somebody would show up on your doorstep 3 days from now. That was a good SLA. A great SLA is within 2 days, they'd ship you some parts. And so that model simply didn't work for what Amazon was trying to do, what their game plan was. So they looked at that as being one problem. The second problem was they were moving so fast and they had so many teams all developing the same capabilities. So you would have a team that was developing the golden chest that would have, they needed storage. So they would design their own storage little subsystem. And you had, the web page was made up of a bunch of different teams. And so they decided at that time to leverage, which was a novel concept, which was a SOAP architecture, where essentially it was the predecessor to microservices, where you would design a service and it would do one thing and one thing only. So you would have a team that would design a storage service, and it would be defined by its APIs. Sound familiar?
Very.
So they would have these teams that would develop these components that were defined by their APIs and only their APIs. And everybody would start using those. And if they weren't good enough, a team could develop their own storage service, or the team that owned the storage service could decide they would implement new APIs and new capabilities. So they took this concept of not needing all this monolithic hardware and not needing this monolithic software and this distributed nature of doing the same job many times. And Andy went off and he wrote the original paper. And everything we do in Amazon is written in using something called the working backwards process, where you start with the customer and you work backwards from a press release and an FAQ, frequently asked question document. And you define the problem and you define the solution. And it's a really simple, but yet really hard process, because you need to start off with the solution written as understood by a customer on the day you launch. So you really have to know what you're doing, because you're defining the customer experience. So Andy went off and he wrote the paper that eventually became the blueprint for AWS, where you'd have compute services that could be vended internally or externally. And the first services they defined was S3. So they defined a storage service that could be accessed from the internet. And that same service could be accessed from any of the teams building solutions in Amazon at the time. And so once Andy wrote the paper, as the rumor goes, he handed it to Jeff and the team. There's the paper. He's going to go back off to what he was doing, which was running Amazon Music, which he loved to do, because Andy has many passions, but the two that he really talks about a lot is sports. He's a sports junkie, and he loves music. And so he was off to continue with Amazon Music. And I don't know exactly how this went, but Jeff said something to the effect of, "Why don't you go do it?" So Andy was asked to go start a brand new business which eventually was called AWS, and he became its CEO and now CEO of Amazon. So the rumors of Amazon having a lot of spare capacity and somehow AWS popped out of that, not really a true rumor.
Oh, I love a good myth debunking.
What it really was is the ability to develop these microservices and then to build them on top of commodity hardware that you could buy in very small chunks, which the rest of the world eventually came to know as software-defined anything.
So it really comes down to that business model of trying to build something the customer wants versus looking at the tech you have and saying, "Hey, we have all the storage, might as well build something."
That's exactly right. They definitely had a problem internally. that they needed to solve, and they realized that problem could be helpful for others. Now, of course, it wasn't a leap of faith that it could be helpful for others. There were retailers at the time that came to AWS and said, "You guys seem to have figured out how to sell things on the internet. Can you sell our stuff on the internet?" And that's when we started to realize there was a real business here, because we didn't, at the end of the day, want to build their business logic, but we could support their business logic by having it run on our infrastructure.
Why did AWS Engineering appeal to you specifically?
It was really a buildup from my first two jobs. At Digital Equipment Corporation, it was a great place to learn how to be an engineer. In those days, there was no such thing as a developer, an architect, a QA person, whatever the case. We weren't even product managers at the time. If you were on a product tag, you're it. So there was nothing that needed to happen that wasn't your job. And so you really learned how to own a product. And not only did you own a product, you used it every day. When I developed at a time terminal service, which was a way of connecting terminals to timeshare systems over Ethernet, excuse me. Every day when I pressed the return key, I logged into my device. And if it wasn't working, we knew it. Right? And so we were always living under the bridge that we built. I learned how to be a great engineer, or at least a reasonable engineer. When I went to EMC was all about the customer. At DEC, I never saw our customer. And we learned how to build great products, but we never really saw our customer as engineers. When I went to EMC, it was all about the customer. Every one of us carried a pager. On day one, you got your badge and you got a pager. And so you were always on call. And you learned when that pager went off, like you dialed in, you were ready, and you solved customer problems. So you really understood how to connect to the customer. It was a little bit reactive, but you were very connected to your customer. By the time I got to Amazon and AWS, I understood how to own product, and I understood the importance of customer. But I wasn't quite ready and prepared for the Amazon culture, or that is, I didn't understand the Amazon culture. So a lot of people on LinkedIn would say, I endorse you for cloud computing. And I'd be like, please don't do that. I don't know what I'm doing. About 3 years in, I allowed them to endorse me for cloud computing, because about 3 years in, I said, I think I know what I'm doing now. And if you combine the two things that I learned at DEC and EMC with the culture of Amazon, which is working backwards from the customer, not being reactive to the customer, but being proactive in understanding their needs, in consistently launching capabilities, inspecting those capabilities at the level of second and penny, not at the level of millions of dollars and quarters as in time, not quarters as in money. When you start looking at things in terms of seconds, milliseconds, and pennies, you really start to understand how your customer is using your product. So working backwards from the customer, launching, inspecting those capabilities with data, and then turning that into a closed loop system. I was really able to take what I'd learned in the past and apply it in a very new way to the present. I was asked by my then manager, an amazing person, Alyssa Henry, who is now an executive vice president at Square. About 3 months in, she had asked me, she said, "How are you doing?" I said, "I'm doing really well." And she goes, "This place isn't too much for you?" I said, "No, I don't think so. I think I was prepared. I think I was built for this place." He says, "It runs a little faster, but I think I'm ready." That's how I see, the continuum from DEC all the way to Amazon. I was trained well to get here.
What a beautiful arc. Can you provide some scale and context for the size of AWS? How much data do you manage daily?
Well, I can't give you exact numbers, but we see our businesses growing in terms of customer adoption and usage by double-digit percentages, multiple double-digit percentages year over year.
That sounds like a party.
So I want you to think about that for a minute. And publicly, we talk about the fact that AWS this year will grow roughly 36 to 38%. And that is AWS all in. When you look at services that are newer than that, services that aren't 16 years or 17 years old, services that are 3 years old and 5 years old, those services are growing at a multiple of that. It's it's pretty incredible. And here's the thing that people might not understand. I think it's fascinating. So S3 was the first service that we launched. It's actually a slightly misnomer. SQS was really the first service we launched. But S3 was the first service that went GA. And S3 has been re-architected and rebuilt while the car is going around the track at record speeds at least 4 times.
Sheesh.
In the last 17 years, because everything we do, I say this tongue in cheek, everything we do is pretty straightforward, except for the fact of we have to deal with scale and growth.
It's easy as a one-off.
Everything changes with scale and growth. You get about 3 to 4 years out of your architecture before you have to start transforming it, just based on sheer size. Funny story, when I was interviewing for Amazon, and Amazon was the first job I ever interviewed for. Wasn't well prepared either. Didn't study. Don't know how I succeeded. That's another story. At Amazon, everything rolls uphill, nothing rolls downhill. Meaning that as you become more senior, you're expected to understand everything in your business that is below you. There is no, I take my posse to a meeting, my posse explains to the CEO what's really going on. You show up to the meeting, you explain what's really going on. So it's a from an engineering perspective, it's a really challenging job because you're leading these organizations and you also understand your technology, at least down to the architecture. So when something like log4j happens, you pretty much can understand immediately what your teams need to do. The nature of scale and architecture is something that you have to understand as a business leader. And you have to give your folks the room to make these adjustments as you grow, and you have to understand when it needs to happen. So it's a fascinating business. It's changing every day. It's scaling every day. And, 3 years from now, we will be exponentially different and larger than we are today.
We'll be back with more in just a moment. This podcast is sponsored by Renesys. At Renesys, we continually strive to drive innovation with a comprehensive portfolio of microcontrollers, analog, and power devices. Our mission is to develop a safer, healthier, greener, and smarter world by providing intelligence to our 4 focused growth segments: automotive, industrial, infrastructure, and IoT, that are all vital to our daily lives, meaning our products and solutions are embedded everywhere. For more information, visit our website at renesys.com. And we are back with Wayne Duso. Wayne, are there any hidden or behind-the-scenes technologies that people would be surprised to hear about, but you're especially proud of?
Yeah, I actually, that's a really interesting question. We are a technology company, but we're not driven by technology. This is something that's radically different at Amazon as well. I've been in a lot of companies where you're constantly looking at brand new technology and trying to figure out how to leverage that technology and drive value for the company, for customers. And based on our working backwards process, we look at problems and say, how do we solve that as quickly as we can? And often quickly means not using the latest and greatest technologies. And because most technology is wrapped, again, in APIs, we can constantly change the technology underneath the APIs without anybody knowing. I just mentioned a minute ago that, S3 has been re-architected a number of times over the years and has used numerous technologies and will continue to do so. But I would say that the work we've done in the last, we'll say 6 years, with having acquired a small company out of Israel called Annapurna, and the chips that we're developing. Because again, if you think about what I said around, most commercial technologies contain capabilities we simply don't need, that we have to pay for and never use. So all the way down to the chip level now, with Graviton and Trainium and like chips like this, we're designing capabilities. We're designing at the chip level so that we can deliver greater value to customers, and only that value, paying only for that value. I think this direction, including our creating our own SSDs, solid state disk devices, is examples of where we will invest in order to drive cost out, drive performance up, and drive greater value to our customers. It's pretty amazing. Like when I hear about some of these projects, and we talked about creating our own SSDs years ago, and why? Why? Because a lot of the firmware on SSDs wasn't what we wanted. It wasn't meeting our needs. And you can't get the drive vendors to change their firmware just for you.
No.
And it's quite unreasonable. So instead of asking for unreasonable things, we decided to take it upon ourselves to go build our own firmware.
Fascinating.
Right? If you think about our scale, it's very effective.
It's a little crazy to just say, we'll build it ourselves.
So that's one example. There's many examples. That's one example of things we're doing under the covers, if you would. By the way, I want to mention, and given the audience, so I love engineers. I love this industry. I really do. Like, as much as I'm a geek and I love technology, my fundamental role in the last probably 10 years is not technology, it's people. That's my software. And my job is to build leaders so that we can build these businesses and build these teams to build these products for customers. It is a closed loop system. It's a fuzzy closed loop system, but it's a closed loop system. Everything that I do today is in support of young engineers, mid-career, and those journeyman engineers that exist, and hardware engineers sometimes I think are overlooked because of how much software we produce today. Like everybody thinks everything is software defined, and being a software engineer is the only career. But all of this, the cloud isn't magic. It all runs on hardware, right? Material science is important. Electrical engineering is important. Computer systems engineering is important. Systems engineering is important. Yes, computer science is important.
Preach.
And I want all of these folks to understand how important what they do is to the ecosystem that we build. I'll give you an example. One of the products I own is the Snow family of products and devices at AWS. It's a device. It's a piece of hardware. It's a hardened piece of hardware. It's actually an amazing piece of hardware. You can drop it off a building and it still works. And all of this is the results of industrial engineers and electrical engineers and materials folks. Without it, the internet won't run. Right? So I want everybody who's listening to this to understand that within this really big and amorphous world of cloud computing, at the very heart of it are the chips that I'm talking about. It's the systems that I'm talking about. That is what all the software folks, have at their disposal to build these amazing products. So if you're a hardware engineer, you're a double E, love you.
What skills do you find are most important for the hardware engineers you interact with?
Well, that's a great question. If you think about this notion of working backwards from the customer, the closer you get to the hardware, the closer you get to materials, the closer you get to the physics, you're really far away from that end customer. But you're not. You really have to double down and think about, well, who is your customer? And what is that chain of customer all the way to the end user? So I think it's a little harder than it would be if you were a front end, engineer working on the customer experience, the end customer experience. You get to touch the end customer and talk directly to them. If you're a hardware engineer, get involved in some of those meetings. Get your nose into the dialogues that involve customers and understand what they're thinking, what they're saying. You're not going to talk to them about the physics of your chips. Maybe you will. If it's GPL, maybe you will. If it's Los Alamos, maybe you will. Right? But understand your customer and then that chain of customers all the way through to the software engineers and systems engineers that are actually going to take your products. And be really open-minded. It's really easy when you're building the technology to be a little insular because you're solving really hard problems. Make sure that you have those tethers out to your customers. It's important.
That's good advice for sure. I'd love to touch briefly on the concept of virtual machines and serverless systems.
Bring it on. Bring it on.
Are there actually servers and machines and I'm just pretending there aren't?
Yes, the cloud is not magic pixie dust. And serverless doesn't mean that it runs on universal magic.
Shucks.
So let's give our shout out to people like Diane Green, who was a founder of VMware. A handful of years ago, her and her co-founders forming VMware identified a really interesting problem that the vast majority of CPU cycles were simply sitting there idle and not doing anything. So people were way overbuilding. And in that time, the notion of sustainability wasn't really a concept, right? It was just economics. It was just how much money you were spending on IT. Roll forward to today. Sustainability is huge. If you're an engineer, software engineer, hardware engineer, any engineer, like how much energy you're using, how efficient you are, isn't just an economical issue, right? It's a sustainability issue. And in fact, recently AWS launched essentially a carbon footprint calculator for folks to be able to see, based on the services they use, what their carbon footprint will be today and 3 years from now. And you can make choices. So let's talk about that in serverless. Let's talk about that in virtual machines. Virtual machines, pretty simple concept. You have a hypervisor running on the hardware. So it's, if you would, it's the based operating system on a machine, on a physical machine. And it slices up, the various resources, the virtual versions of that, and allocates those out to individual applications. And collectively, all of those applications, we hope, in the best day, will consume near 100% of the resources. If you hit 100%, you're generally in trouble. But let's say in the 90% range. That's interesting, but it turns out that even that's somewhat inefficient. And not only is it inefficient, it requires that the application developer or some system developer understand how they're utilizing those resources. They need to plan it out. So you're still worrying about infrastructure, just it's virtual infrastructure. It's a lot of work for not a lot of gain. It's what's often referred to as heavy lifting.
Okay.
Serverless introduces another level of abstraction. And before you get to serverless, let's talk about containers. So containers is a level of abstraction on top of virtual machines at some level, where you're further abstracting the resources in a way which allows you to think less about the machine or the virtual machine and more about how microservices or how containers interact together in pods or in clusters. And this is another level of abstraction if you think about a service like AWS Fargate, which not only helps you containerize your applications, but allows you to not even plan how those containers run. It will automatically auto-scale, if you will, containers or pods up and down based on the needs of your application.
Okay.
So that then brings us to serverless, which introduces the notion of software as a function. So for serverless applications, you by and large write a set of functions. And that set of functions will interact with one another, each other, other functions. And as you make API calls into your services, they will scale based on the number of API calls that come in. Now, that scaling happens without you needing to think about it. So if you have a mobile app and you have millions of customers, we'll be practical and say hundreds of thousands of customers that hit that one API at that exact same moment, it's not all funneling to a single microservice that has to scale, but it's hitting an API service that will concurrently spin up that 100,000 functions, execute them, and return their results. And then when that is done, and you don't have 100,000, but maybe you have 10,000 or 1,000, all of that infrastructure scales up and down elastically based on that need. Now, the application developer or the microservice developer or the function developer doesn't have to think about that. They have to write the function once, and the infrastructure will scale up and down elastically based on the adoption in the user community and how they interface or interact with that service. Now, of course, none of that's magic. Behind the covers is virtual machines. Behind the covers are containers, and below that, under the covers, are all this great hardware. This compute, networking, and storage hardware that enables all that to happen, which is really important. Why I bring this all the way back to the beginning. When you sit down any young software systems engineer and you say, here's a 6502, here's an i7. This is what you're doing. But then when you scale it up, this is what we can produce. And this is what amazes me every day. It takes a lot of really great people to do this work. And that brings me back to my software, which is the engineers.
As someone who's crashed servers, I will say this feels a little bit like magic still. Maybe that goes back to the sufficiently advanced technology is indistinguishable from magic. I would love to talk a little bit about networking, and we'll start with an easy question. How would you define data networking?
Well, at its most basic level, so anybody who's familiar with the 7-layer ISO stack of networking, at its most basic level is the exchange of data in well-formed packets that traverses some local area or wide area network. So it's a layer of protocols. Each protocol defining a packet format and some semantics, and then those protocols work together to accomplish some goal.
What does the next generation of data networking look like, and will it be recognizable even 20 years from now?
What's most interesting about data networking, so I've been a networking person my entire career. That's where I started. And what you find is that we define new protocols. We define new network technologies, speed. If you think about it, gigabit speeds at one point was thought to be amazing, and now we're talking about terabit speeds and beyond. So the speeds of the network will increase. The pervasiveness of connectivity will continue to increase. At the beginning of our talk today, we joked a little bit about low Earth orbit systems for broadband. These will become pervasive in the next few years. Starlink is one. Amazon, AWS has a system which is now deploying, and others do too.
How will Amazon putting up satellites impact what you and your teams are working on?
Well, if you today, AWS and Amazon has a worldwide fiber network. We have about 300 points of presence around the world. And those 300 points of presence enable customers to connect directly to our fiber. So once on our fiber, we're able to accelerate their traffic around the AWS network, greatly decreasing latencies and improving performance for them. But they still need to connect to one of those 300 points of presence. Right? And between that and wherever they are, they're still connected in some way to some form of internet. With a low Earth orbit system, the ability to have a straight shot to the satellites, further decreasing latency and improving performance exists. Not only that, but there are many places in the world that do not have access to these points of presence, no matter how many points of presence you build. The world's a big place. It's a tiny place in the universe, but it's still a big place for humans. And on occasion, when I'm riding my motorcycle out in the Midwest of this country and you look out into the vastness of it, you realize how tiny you are, right? How big a place this is. So with, a satellite-based system, there'll be many places in the world that don't have access today that will have the same quality of access that a lot of us appreciate. Now that will become pervasive. And with that, think about the innovation that access will bring, because that enables them to build their own businesses. It enables them to get immediate access to knowledge they don't have today. So that's how I see it changing the world. That's how I see us helping do that.
It's almost an extension of what cell phones have done for a lot of parts of the world. I I now would like to play a quick game of Would You Rather. Would you rather have infinite bandwidth but be stuck with your current storage capabilities, or infinite storage capabilities but be stuck with your current bandwidth?
Oh man, do I like ice cream or do I like cake? Both, please. At the same time.
Infinite bandwidth and infinite storage sounds good to me too.
Yeah, infinite bandwidth and infinite storage is the goal, right? So I'm not going to. We'll do a Kobayashi Maru. I refuse to play by the rules of their game.
Okay, speaking of, if we're gonna go nerd culture with it, what computer themed movie would you prefer to get sucked into if you had to get sucked into one? Tron, War Games, or The Matrix?
Oh, War Games for sure. Do you want to play a game? That's a classic.
Oh yeah, I watched it for the first time like a year ago. I'd never.
Come on.
It was a little bit before my time, so I had to like go see that and like Hackers I'd never seen and a couple.
Yeah, it's got like high school romance and in 96 baud modems.
Sadly, Wayne Duso, we are out of time. Thank you so much for being here. It's been a pleasure.
You're welcome. Thank you for the time today. This was a lot of fun.
Well, it's fun for me too. And really, the whole season has been a blast. Thank you for joining me today and this season in the lobby. We're already preparing for season 4. If you like this podcast, please tell your friends and coworkers about it. Podcasts are great listening for those holiday road trips, and flights are even just hanging out at home. And you can find this one on all major podcast platforms. I'm Daniel Bogdanoff. Thanks for listening, and I'll be back next season.